Good afternoon, Western Australia, and welcome. Inspired Squad Session 4, Mathematics Application Program. This afternoon's topic, time series, smoothing and deseasonalising. 15th of September. Hey, that's my birthday. My name's Brian Lannon. Yes, and it's my birthday today. But enough of that. You don't want to hear from me. You want to hear from Mr. Crothers, the man from Safety Bay, the mathematics humorist and data analysis expert. Time series and smoothing, and also that mystery of seasonalising and deseasonalising data, that seasonal index. We have some interesting problems to work through this afternoon, so at the ready with your calculators in hand, and see who can be the first to type in solutions and answers into the chat space. Over to you, Jody.
Thanks very much, and welcome back. I'm looking forward to this session. Time series and smoothing and deseasonalising data is a great topic to be covering. For us in Western Australia, we've been doing it differently. So this is the first year we've actually used seasonal indices as such. So your teachers have been on a learning curve too, along with you as the students going through this stuff. So I'm looking forward to getting a hold of the screen from Brian. And when I do that, we'll take you through what SCARS is telling us about the topic, and then we'll take you through some questions on how to use your calculator in the most efficient way to be able to answer the questions that are being provided. Thanks to everybody who's come along, and also thanks to those who are listening to us on YouTube when they replay these sessions.
Yes, apparently we're getting quite a big YouTube audience. The ball's in your court there, Jody. So ready for share screen?
For it to come? It's not here yet.
That's interesting. I'll do a grab and a resend. Yes, that is something we have noticed, is that there's been quite a lot of follow-up on YouTube, which is very encouraging. Good to see. And obviously, this series is becoming a part of exam preparation for quite a few people. Ball in your court now, Jody.
No, it's not yet. Still sitting with you.
Well, that is interesting. So we'll try sending this across for the third time. And you've disappeared on there, mate.
I've disappeared.
Disappeared.
Okay. That's going to prove interesting. Still here, according to me.
You're still there, but you're no longer a panelist. We will change that.
Am I still there or not?
You've dropped off the list of panelists, and I don't know why that has happened.
I'll re-log in again. I'll be there with everybody in a second.
We might have to try that. Meanwhile, I'm going to switch to my screen. Special greetings to that PF fellow who's tuned in. It's a very quiet setup, PF. Okay, just while we're waiting for Jody to come back into the show, we will take a look at some initial problems. First of all, considering the references to time series and smoothing and deseasonalising as this appears in the WACE syllabus. And you see here that the time series is the identification of trends, time-based trends over a time-based direction, and particular consideration to seasonality. That is where things we notice a repetitive pattern of a cyclic nature. We look at processes that can be used to smooth data, such things as a moving average, and also centered moving average and moving median. And we look at this business of calculating seasonal indices to see the effect. For example, it might be in summertime, where due to warmer weather, it may impact on the number of ice creams we're selling, for example. And we will be doing our data analysis as we showed last week, where we will do linear regression. We will fit things into that model and then have to re-seasonalise the value to see what it would be for a particular month or particular time of the cycle. So we'll see if Jodie's back in. I'll stop my screen here, send the ball to Jodie.
That's great.
And it looks like it's happening now.
Good. I think we've had some issues with a puppy dog and her tail. And
we have indeed.
Okay.
Okay. Back into it.
Wonderful. So you've just taken us through talking about the scars of things, what we've been going through, which is good, the data investigation process. And then we get to the stage, what is seasonal adjustment and why do we need it? It's something we hear about in the media and the news. The government loves seasonally adjusting data. So I actually went to the Australian Bureau of Statistics to have a look at what they call seasonal adjustment and what they do with it. And as you can read, seasonal adjustment is a process of estimating and then removing from a time series influences that are systemic and calendar related. So they're removing the cyclical nature. Observed data needs to be seasonally adjusted, as seasonal effects can conceal both the true underlying movement of the series as well as certain non-seasonal characteristics which may be of interest to analysts. So it allows us to see the trend. What is seasonality? The seasonal component consists of several effects that are reasonably stable with respect to timing, direction and magnitude. It arises as systematic calendar-related influences such as natural conditions, weather, times of the year, business and administrative procedures such as start and end of school terms, and social and cultural behaviour such as Christmas. If you were to have a look at the sales of Christmas cards, they definitely peak at one time in the year. So if you want to go to the Australian Bureau of Statistics...
Would that be Easter?
Yes, always.
Yeah, okay. Just clarify.
So I've got the website reference there, www.abs.gov.au. It's actually a good source of data and source of graphs and explains things in some detail. And if you're going on to do more statistics at university after you do this, probably worth a look. But I think the key for today is taking you through a series of questions and showing you how to use your handheld when necessary to be able to answer a question, and when you don't actually need to use it. So I will just move my PowerPoint across so you can get access to it, and move my calendar across, calculator across, so you can see what's happening. Here's some I've prepared earlier. We'll go through and we'll start from scratch. A new document, and a calculator page ready to go. So having a look at our data makes a pretty pattern, and we can see a cycle. You've got peak, then trough, then peak, then trough, then peak, then trough, then peak, then trough. First question is, explain why a 3-point moving average is used. Let's have a look. To go from one peak, so the peak from 4 to the peak at 7, you go 1 point, then from 4 to 5, 5 down to 6, 6 up to 7. So you've 1 point here. So you've got 1, 2, 3, and we're back to where we started. Same spot in the cycle. 1, 2, 3. 1, 2, 3. 1, 2, 3. So there's a pattern, 3 points to a cycle. So we can start at any point here, such as this one, go 1, 2, 3, and we end up at the same point in the cycle. And that's 3 points, so we use a 3-point centered moving average, or a 3-point moving average in this case. Next one is calculate the value of A. A is down here at 13. We could go 13, or A looks like it's 8, which is nice. Well, the value of A is 8. Well, the original data is at 0.8, but we want to have the smooth data, A. So a 3-point moving average, we use 3 pieces of data. The one before, the one afterwards, and the point it's centered on. So we would go, make it a fraction. We'd use the first point, 4. We'd center it on 0.8, which is the point we're looking at for A, and then we would add the next point for 14, which is 6, and we divide it by 3. We've got a 3-point moving average. We've got 3 full points we're taking into consideration. We hit enter, and the value is 6. Very straightforward. Now, to plot the 3-point moving average on the graph simply becomes an exercise in plotting the points. But notice, there is no value for 1, there's no value for 18, because in using the 3 points for the centre moving average, we lose a piece of data there. So we're going to go from point 2 through to point 17 to be able to do this. And you simply put the dots and have the pieces of data go through. So we can go through, we can draw lines. So the 2.33 is on 2, 2.33, which is about there, and that goes up to 3 is 3, so it's about there. So that's the first part, from point to point. Next part, we can go from 3, which is at 3, 4, which is 3.67, go across there, and we move through. As you know, with it, as you do it, a lot easier. So we hit 17, it's 7, it's up there. So we go through, mark your points, be systematic, and you'll fill in, and you'll end up with a smooth value through. And we smooth the data. We're removing the peaks and the troughs. We're smoothing the data. And that's what this data points there relate to the points on this line that goes through here. So that's how you plot it. And you plot it by hand using a pencil, preferably 2B, something so they can actually see it when they try to mark it. So at this stage, we've only had to use our calculator for one calculation. We could graph these points on the calculator, but we need to get it on to the piece of paper. And for 3 marks, graphing the points from here and then moving across is all you'll need to do. So, that was a quick question. Handy notes page stuff. The beauty of the TI Inspire, for me, is the notes page. So we can go, create a new document. No, I don't want to say that. In the new document, we're going to have a notes page. And we can pre-prepare, knowing they're going to ask us some of these things. They're either going to ask us to calculate a 3-point average, or they're going to ask us what the missing piece of data to make the 3-point average is. So if you've got a missing value, and I've given you the 3-point moving average, you can use your solve command. So I would go 3-point moving average, Control M gives us a math box, and then we can actually set up our equation ready to go. So 3-point moving average, I can have 3 plus x plus 5. And a lot of situations, I'll give you the centre moving average point. So in this case, it could be 4.2. And you want to know what the actual value was. So we solve it for x. And there's the value. So we can set these things up. 3-point moving average is fine. When we hit the 4-point centre moving average, which we will have covered in class, you've got to realise, and I'll steal this one, Control C, Control V. When you have a 4-point centre moving average, you're using 5 pieces of data, so you're actually using half of the piece of data before, so 0.5 times by a piece of data, plus another piece of data, plus your missing one, plus that, plus half of the last piece of data, which in this case it will be 6. And we divide that by 4. We have 4 full pieces of data. I've lost a bracket in there which didn't like me. So we've got half of the first piece, the next one, the missing one, the next one, half of the last one. So it's 4 full pieces, 3 full ones and 2 halves, equals the centre moving average. And we've got our value. Handy to set those up. 3-point, 4-point. You have a 5-point, which would just be moving average. A 6-point, which would be centre moving average. If you've got 3 or 4 set up, it'll just save you a couple of seconds in the exam to be able to go through, and you're confident you've already got all the information in there. That becomes vital time factor as you go along. So, notes page, you can set up some factors. While you can enter the spreadsheets and all the data and calculate the moving averages, that's useful, but in exam type situations, as we'll see in the next question, they very rarely give you that straightforward algorithm. It's normally finding missing pieces of data to go through and solve. Okay. Now we're going to work through an exam type question to see where the calculator can be used. So this one, and we'll see it in various forms, the table and the questions, is the sales of fishing rods. From 2011 through to 2015, they've done it quarterly, January, April, July, October, and so on. And because the table of data looks like this and it's quarterly, for me already it's saying it's probably going to be a 4-point centre moving average. But then I'm going to go through and have a look at the actual graph of the data. So I'll start with a trough. Nice to start with a crest or a trough just to go through. So it goes October to January to April to July through to October. So it's going 1, 2, 3, 4. And as we thought, it's a 4-point moving average. Which, if you did it as a moving average by itself, it's not centred on a piece of data. So that's why we use a centred moving average. So the half of the first bit, half the last bit, 3 in the middle. So we can go through and find it out. So let's go through, have a look. Comment on the trend of the sales of the fishing rods. 1 mark. So the trend is just purely through having a look at the graph. So the trend, it would appear to be a positive trend with sales increasing over time. Which month appears to have the highest sales? Let's have a look. Back to our graph. This month, this month, this month, this month, they all correspond, and they're all January, which in terms of fishing rods isn't unexpected, especially in Western Australia. Great time of year to be out fishing. Go back. What is the length of the cycle? Can be answered in 2 ways, and I would suggest putting both the ways. It moves 4 points is the cycle, But in actual fact, it's a 12-month cycle, isn't it? It goes from January to January. So we take it through that way. Next part, circle the third cycle. We start here in January and go to January, so that's 1. And January is 2. So the third cycle would be from this January to this January. So it'd be in here. So I'd actually get out the circle and do it that way. I probably wouldn't do it solid because they're probably rather annoyed with me there. Format the shape and we'll make it no-fill. Close. So the third cycle, this is where the third cycle is, from this January to this January. So we know where it is. That's good. Explain why a 4-point centre moving average is suitable for this data. 2 points. So let's start with, the cycle consists of 4 points. So a 4-point moving average is appropriate. However, a moving average needs to be centred on the months, or the data points, so we need to centre it, so we use a 4-point centre moving average, so that each score is going to be opposite a time period, not between them. So a 4-point centre moving average is what's needed. Okay, we hit some more data here. Let's bring up the handheld again. So, says here, explain carefully while the forward centre moving average for October 2011 is equal to 4. So here is October 2011 is equal to 4. Well, to explain that, I'm going to demonstrate to the people why. So I'm actually going to do a mathematical calculation why it is. So I would actually go through, remembering it's going to be a fractional. I'd have 0.5 lots of my first piece of data. 0.5 times the first piece of data we're using is 4. So it's this section. 1, 2, 3, 4, 5 are the 5 pieces of data we're using. It's half of 4 plus 3 plus 1 plus 7 plus 0.5 again, lots of the last one, which is 4, 5, 6, 7, 6, and over 4, because it's a 4-point centre moving average. We're using 4 whole pieces of data, 3 full ones and 2 half ones, and if all comes out smoothly, the answer is 4. And this would be my justification explaining carefully why. We talk about using the formula for centre moving averages, half the first piece, and the like. We do the calculation and it's equal to 4, which is good. Now the next bit is calculate the value of P. P is actually a number of fishing rods, show or working. Now if we go back to our original data here, here's P here, number 14, which is April 2014. April 2014 is up here. I could go up here, and I reckon it's 7. And looking at the graph, it's probably going to be 7 whole numbers. But the question we're looking at says show all our working. So it actually wants us to do some calculations. I'm going to go back to the notes page I made before. Here are the 5 pieces of data I'm working with. So the first one is 5. The next one is 9. The next one is P. The next one is 7. The next one is 5. And we worked out the centre moving average for all those ones is actually equal to 7. And we want to solve that for P. In this case, we change the variable. And P is equal to 7. So, looking at the graph, of the data, P was equal to 7, through our calculations, P is equal to 7 too. So when you do your calculations, you won't have the solve bit. You'll just have this part here. You'll have that down, and then you can have P is equal to 7 up that. So that's showing them that you know how the formula works, what you're doing, and then putting the correct mark in. What it also allows you to do, if you accidentally type in a number and a mistake, and you calculate it, you can actually show them the working out process and make yourself being able to access part of the marks, if that's what's required. Wonderful. The next one's asking us to sketch the 4-point centre moving average on the graph below. So, just asking us to take these values here and sketch it on the graph below. Rather than go through cumbersomely like I did before, here's what I prepared earlier. Notice I've actually put a little marker here. Dash, dash, dash is the 4-point centre moving average. So I've actually been able to go through, put the points through, and have a look. So it only goes from July to April. From July to April, because we don't have 4-point centre moving average values for the first two and the last two, by the nature of the way we do our calculations. So there we have a couple of marks just by going through and graphing the points, doing it neatly, doing it with a pencil so you can't make a mistake, but doing it with a dark pencil so they can see, and giving the information so you can actually see which line you've drawn. And that's important. Go to the exams prepared with the right equipment. Okay. Now we're going back to our data. In January 2015, here's a horizontal version. Here's a vertical, 11, 9, 9, and 8. Cross. They want us to calculate the seasonal index for January 2015. To calculate a seasonal index, we look at the values through the year, and then we look at what part an individual season plays. Some of this you may be able to do in your head, some of them may wish to do in your calculator. It's 2 marks, so it doesn't hurt to actually show a little bit of what you're doing. So you'd go 11 plus 9 plus 9 plus 8. And that's simply the values here. That's totaling into 37. Now, what component of that is January? Okay. 11. Highlight, let's make this a fraction. Over 37. 4. And there we have a seasonal index. And I'm actually going to go up here, change my document settings. It was an auto. I'm actually going to make it approximate.
Yeah. So that's the index particular to January in that year, is it not?
That's particular
so it's the seasonal index of the January.
Of January 2015.
Yep, within the 2015 year.
Yes. So,
and could I perhaps just emphasise there that the key trick to that is the formula seasonal index equals the seasonal value, which in the case of our January there was 11, divided by the seasonal average, which you effectively took by adding them up to get your 37 and then effectively divided by 4. 37 on 4. Yeah, works for me.
Excellent. Okay, this question also gives us the seasonal indices for the other Januaries, which is good. With that information, we can determine an average seasonal index for all Januaries that we're dealing with. And this is what the Bureau of Statistics do and other organisations. So look at what happens in January historically, and from there you can actually come up with an average seasonal index. And the word average should strike up a bit of understanding of what you're doing. So it's simply a matter of taking the values you've got over there on the table, being, and we'll make it a fraction again, we're doing average, which is fine, 1.54 plus 1.33 plus 1.33 plus 1.29 plus 1.19. And that's the one we calculated. I'm doing it the same number of decimal places as all the other ones are given. And we divide that by 5. And we should come up with a value, yep, it's approximately 1.336, which is fine. Now the next part, it says, use moving averages to determine least squared regression line. Okay. If you tuned in last week, you'll be able to have a look at what we do for least squared regression lines. So we go back here and we look at our value here for the 4-point centre moving average. These values here, and we're aligning to these time periods, 3, 4, 5, 6, accordingly. Now we can take
important
our time.
that we get the bivariate data right, isn't it? So that we get the same number of data points on each side.
That's correct. We couldn't have 1 or 2 because there's no corresponding data. And you'll just come up with errors all the time. Same with 19 and 20, there's no data. So what I've done is I've gone in, I've called the first one time, the second one CMA. It doesn't like the numbers and the titles up there. So 3, 4, 5, 6, 7, 8, all the way through to 18. And the corresponding centred moving average is there. So once you take the time to enter that data, and I'll give you a few seconds, then we're going to go through and do some statistic calculations using that data. And, we're going
and a review of what we did last week.
That's correct.
Just one of the most useful little tricks of the whole course, I think.
We're going to go menu, statistics, stat calculations. We're looking at linear regression. It's talking least squared linear regression, which linear regression is. If you were here last week, you would have seen Brian moving squares around to make them small, which was good. So least squares, mx plus b, or mx plus c, depending on how you refer it. Here we go. Our x list, and we've called it to the moving average. No, we've called it with time. The Y list we've called centre moving average. And we deliberately name these things that we recognise, makes it easier. It's saving the calculation to F2, so our regression equation is going to be F2, which is important to know. And all our results are going to appear in column C, which is fine because our data is in column A and column B. So, we hit OK. So here we have it. We've got an M value. We've got a B value. And they're the key ones for what we're looking for here at the moment. We've also got very strong correlation coefficient, very strong determinant of correlation. So there's obviously a huge effect in changing the time as to the change in the CMA. So very accounted for. So we can now create a new calculator page. And remembering that F2 was our equation, here's our line of regression. So it's asked us for our line of regression. We now have it. Let's go back down. Our line of regression, and that's good. Now it wants us to predict the sales of fishing rods in January 2016. So here's our line of regression. It's based on the centre moving averages. January 2016 will be time period 21. So we're going to go F2, use our equation, for the value of 21. That's great. So now we have a value for the centred moving average at period 21. What we now need to do is deseasonalise that data. Well, we've deseasonalised deseasonalised data. Now we need to seasonalise it again. So we need to, what's the effect of January? Well, the effect of January, take that number, and we get a whole number, a large number there, and we multiply it by our wonderful index, which we had earlier. So we'll multiply that by 1.336, which is our January index. Gives us the data. We get 12.48. We'll round that to 12. So we expect to sell 12 fishing rods in January 2016. In terms of fishing rod sales, I hope this company actually sells more than just fishing rods. Otherwise, they're going to go bankrupt.
I would have thought January would be the time.
Well, it's the highest here, but it might just be a corner deli selling a few down by the jetty in Safety Bay. Probably fish. Plenty of bream. So, we've gone through, we've predicted our sales. We predicted our sales based on using the line of regression and then going through and seasonalising it using our seasonal index. Okay. We've got another question to answer, but I'm going to hand that across to Brian.
Okay, mate.
And I'm going to
share the fun around.
Make you the presenter.
Beautiful. Here we go. Share screen. Let's go back to our PowerPoint. And so our next problem here is looking at data across the 2 years. I'm just going to make this a little larger for you. And so this time we've got a counter. So we've moved away from fishing rod sales, and the problem we have here is seasonal data across 2 years. So we've got a month count here, but all up we've got a counter of 24 months. And these are the raw data. Now, we weren't given a context for this, but we could say it might be, well, I was going to say number of ice cream sold, but I thought we'd get more of those in January. It could be a Northern Hemisphere number of ice cream sold from a shop. Maybe that's the case, in which case we're going to get a bit more in July and June, July, August. So we'll run with that as our context. But the first question we've got here is explain why so many of the scores have no moving average, because here's our 12-point moving average, and we've got nothing here for the first 6, and the first one that kicks in is July. And then we're kind of missing the last 6 here. So the reason for that, to answer part 1 of our question here, is that as similar to what the JodStar just showed you with the the 3-point moving average, or then the 4-point moving average, when we get to the 12-point, so the 4-point used actually 5 points, did it not? It used half of the first and half of the 5th, and then the 4 in the middle. Sorry, the 3 in the middle. So what's happening here, to get this value here, we're using half of this and half of the 13th, and totaling all of those in the centre and dividing by our 12. So we've got our values here. So that's why. So basically, to answer part 1, 13 points are used to work out a 12-point centred moving average, and we obviously don't have enough data until we get to the 8th point, where we can go the 7 back and 7 beyond. 6 beyond. 6 either side, I should say. 6 before and 6 after, plus the one in the centre. Okay, so find the seasonal index for January 2014. And again, I come back to that formula that I quoted and the JodStar just showed you. If you can just remember, SI equals SV divided by SA. SI equals SV divided by SA. And what that stands for is seasonal index equals the seasonal value divided by the seasonal average. I have that actually in another little notes page, on my calculator here, but I'm not going to use that one. I'm going to use this here, and I'll just show how we can build this up right from the start. I've got it all mapped out from my practice here, but the feedback that we've been getting from students, and thank you very much for that, is that they like to see how to build these for themselves. So I'll just show you how I've developed this page. First of all, I insert a completely new document, lists and spreadsheets. Now, I started by talking about the month. I won't put in the month now. I'm just going to put in the counter, and then the data. Okay, so it's similar to what you've got on your page there. Now, you see in the first column, I've got the numbers 1 through to 24, and I'm going to show you a shortcut of how to do that. Of course, I could type 1 and then press enter, then 2 and then press enter, and there's various ways of filling down. I'm just going to show you how we can fill data in. You may recall from last week even. If I generate a sequence, I'm going to say that the next term, that is UN, will equal UN minus 1. So any term equals the previous term plus 1. So it's plus 1 more. Now the initial term will be 1. We're going to start with 1. We will count up by 1s up to the 24th term. So what you see on your screen there is just a quick way of entering in the numbers 1 through to 24 in that column. It's reminding me that if I proceed, I'm going to overwrite the couple of numbers that you saw me just type in a second ago. So I've done that. So I've used the sequence command, and here we have our 24 months. Now the data I have to type in manually, so that's from the paper there, 1, 2. Now if you excuse me because I am time conscious, I'm just going to copy from here. Sorry, I need to take it from the top. So I'm taking it from my previously prepared document, and I'll just drop it in here. Got the idea? So the data typed in, and to get that seasonal index, let's first of all work out, let's say for the first year, that is 2014, what was the average there? So let's just work out the sum of the cells A1 through to A12. So this is basically number of ice creams sold. Call that an equals, I should say. This will be the number of ice creams sold. I must start equals for a formula. So that's across the whole year. Sorry, not A, I wanted B. A is counting the months. That looks a bit better. So 51 ice creams sold from this little corner store for the year. Probably need to be getting out of ice cream sales if that's their thing. But then the average of that is then, so the average per month is 51 divided by 12. I'm just going to put that number in here. 51, so it's this value, divided by 12. Okay, and as John Starr pointed out before, if we want to get rid of those fractions, we can go into the document settings and tell it that rather than automatic calculations, we want approximate. So this will give me a decimalised answer. Okay, so on average we're getting 4.25 ice creams per month, and so for this January here, number 1 January, to work out the seasonal index for that January, it's the seasonal value divided by seasonal average. So in here it's going to be equals the seasonal value, which is 1 as you see, divided by that 4.25. Okay, I'll just remind you that formula. So what's going to happen in here, I've got seasonal index, I'm just going to call it SI, seasonal index equals the seasonal value, which in this case is B1, divided by the seasonal average, which is 4.25 for this year. Now if I fill this formula down, for the remainder of 2014, you have the seasonal indices for each of those months. And you see in each case, that's the February ice cream sales divided by that 4.25, the seasonal average. So this is the seasonal value for March, which was 3, divided by seasonal average 4.25, and so on. So when I get into my next year, so there is an argument that we can actually average across the 2 years, but it depends on how it's set up. So in the next year, I'll do the same thing for that next year. So let's take a quick look back at our question. So the seasonal average for January 2014, you saw it was calculated there. It's 0.235, etc. Okay. Coming back to the next part of our question, find the equation of the least squares line using the 12 centered moving average and the counter. Now again, the big danger here is make sure that you have data that match up. I'm just going to show you that. Let's just get rid of this now, and that, and I'll copy the data as they are from the page that you've got, which is 4.46, etc. So it's coming in at July. In fact, just to speed things up, I'm going to grab it from my previously prepared one. Control C and Control V is just so very useful in these documents. And I can also do it from one document to another. So there you can see we've got those in. Now, if I call this the 12 C, oh, hang on, I can't start with a numeric. C for a label, CMA 12. So if I call that for this column, but if I then try to map the counter against 12 CMA, watch what happens. It won't work. Data and statistics, here's the counter, 24 counterpoints. The 12 centered moving average, there they are, but there are not as many, there are not 24 of those. So if I then try to do a regression, I'm going to have difficulty. Okay? Because I've got a dimension mismatch. So what we need to do is what Jody showed you before, is take those values and put them into another spreadsheet. So I've called it Counter 2 and CMA. So so as you can see, I've now only got the 12 values. So the first 6 and the last 6 are excluded. That's very important because otherwise you won't be able to get a linear regression. So putting in a data and stats page, so I've called it Counter 2. There they are. And I just called it CMA. So now things will match up. So when I analyse for the regression, I get the formula. There it is. Now, probably better if I actually do it on a calculator page, because then it will paste it automatically into a function for me. So if I do, using statistical calculations, the linear regression, and my X list is Counter 2, my Y list is CMA, which is my 12-point average. There's the equation. It's the same equation as you saw here. But most importantly, it has copied that into function 2, as you saw from that previous window. So now if I say the function 2 of a particular value, so the function 2 of, we were then asked back in our question, I'll found the least squares regression line. Use it to predict the raw data for January 2016. So use the equation there to predict the first raw data for January 2016. That's going to be the 25th value. If you look at what we've got, is it making sense, Jody? I'm on track there.
Definitely.
So we've got 24 values there from January 2014 through to December 2015. So for January 2016 raw data,
25.
I put in value 25, and so raw. So that is a deseasonalised number, 7.26 ice creams. But to remember to re-seasonalise it, what we have to do is to get the seasonal value, I then need to multiply that by the seasonal average. I'm just going to take that. I should use the 2 years, but I'm just going to take the seasonal average that we had before and multiply it by, I'm just going to use the seasonal average for the first year, although we did have a couple of years, so we could be more accurate using that. I have that here. That's that value that we had before. So I've only used the data from 2014. We'd be more accurate by using 2014 and 2015, but the re-seasonalised figure is 1.71 ice creams. You happy with that, Mr. Jodstar?
I'm always happy with ice creams.
I shall send this back into your court then. Do you have more to add?
No, just to follow up and just to talk to people about some of the things to remember.
The key points.
Key points. Let's go down to the key points. The key points things to remember are.
Okay, ball is back in your court.
Good, and I will go through and share my screen so everyone can see it. It's good. Things to remember, as the Cubs and Scouts used to be prepared. Use your notes pages. So if you can have your calculations for your centre moving averages and finding a value given the centre moving average pre-prepared, you can save yourself some time. You also need to remember, got to type, that data points need to pair up. So if you don't have a centre moving average for it, then don't include the time part to start with.
Understand.
So
yep.
Don't have 1 or 2, start with 3. Go from 3 and then 4 and then 5. Make sure the data points pair up, because if they don't pair up, you're not going to get the correct answers.
Which means either retyping the data or using that copy and paste as we demonstrated.
And also remember the regression equation. So it's going to be F1 or F2. Remember which one it is so you can use it. It will make your life so much easier. Remembering you can go F2 at X, and that will give you your line of best fit if F2 is a regression equation. It will give you that least squares line of regression so you can actually pick it up and use it and write the answers from there.
Just thinking, Jody, do you want to maximise that screen you're on, Jodstar? So it fills up the whole page for us. That makes it easier to see, thanks. Yep.
Good. And we'll take it from there. Anything else?
Just for old fellas like me with crook eyesight, you know.
And we'll leave that there. Thanks very much for paying attention. Next week's our last session, which we'll be looking at the finance solver. Great thing, useful to use. We'll give you some hints and tips about finance and finance questions and what we can do with that and how we can use it.
Yes, certainly. And it will also mean a revisit to our sequences, the sequences idea, and as it is actually set up, those number patterns and sequences emphasised in your syllabus is particularly for financial applications. So we'll look at the sequences for that, and as the Jodstar said, the real time saver, but as long as you know how to use it correctly, is that TVM solver. TVM solver is wonderful. There are different ways to operate it, and we're going to show you the ways that we consider are best. So thanks again to our safety fellow from Safety Bay, the Jodstar, and thank you, students, for tuning in and offering your comments along the way, and we look forward to seeing you for the final session next week. Until then, cheerio.
Bye. How you going?